Let's start. UPCAST seeks to provide a set of universal, trustworthy, transparent, and user-friendly data market plugins for the automation of data sharing and processing agreements between businesses, public administrations, and citizens. Setting a price for data is one of the key challenges that providers face in their go-to-market processes. UPCAST Task 2.3 within Work Package 2 deals with data pricing and valuation, and has already developed a first version of its static pricing plugin to help with this challenge. Second slide. UPCAST static pricing tool aims to provide sellers and buyers with a hint of the market price of a dataset, taking as inputs its metadata features and based on market prices observed in already existing commercial marketplaces. It uses this information to train machine learning data product classifiers and price regressors. Classifiers learn the criteria used to label a dataset as belonging to a certain category and helps label new data products homogeneously. Price regressors learn the features that data providers and marketplaces are using to price data products, and they can predict what the price of a new data product would be. An AI explainability module is also built in to provide information on the key features of data product that led to that prediction. Next slide. A data scraping process produced information about 200,000 data products from more than 2,000 vendors and included more than 10,000 price references. Those data price references contain metadata features like the description of the datasets, their time and geographical scope, the units of data they contain, their update frequency, format, or delivery methods. More details about this training data, which was also enriched during the project, can be found in the papers Measuring the Price of Data in Commercial Data Marketplaces, published in the first ACM workshop on the data economy in 2022, and Understanding the Price of Data in Commercial Data Marketplaces, published in the IEEE International Conference on Data Engineering in 2023. Next slide. UPCAST static pricing plugin uses BERT sentence transformers to encode data product descriptions, storing valuable semantic information and new DNN classifiers and regressors that were designed and optimized to improve the performance of state-of-the-art pricing models and to make them more generalizable. Okay. DNN classifiers have been optimized and trained to fit the categories used by AWS, the marketplace containing more products in the training sample, achieving F1 score above 0.88 in all cases. The tool uses random forest and DNN models to fit the prices observed in the market. The range returned corresponds to the maximum, the average, and the minimum price returned by 10 such regressors trained over 5 different train test splits of the input data. New DNN regressors clearly outperform state-of-the-art and significantly increase the performance of previous models.
Now we move into another one of the key aspects of this plugin, explainable AI. Explainable machine learning, or XAI, is about making the complex decision-making processes of machine learning models understandable to humans. Now, why does this matter? First and foremost is trust. We are more likely to trust and use models if we understand why they made certain predictions. The second concerns debugging and improvement. Understanding how a model works helps us find any weaknesses or biases, and we can accordingly make improvements. Another very relevant reason is AI regulation. Use of AI across most domains or verticals now require transparency and explanations for AI-powered decisions based on regulatory and legal requirements being implemented across the EU. As you can see from this figure, the input data is fed into the machine learning models and explainability methods are applied to these models, which then, along with the predictions obtained from the machine learning models, we also get the explanations, which are then sent as a response to the end user via the API. One of the main techniques used in explainable AI is SHAP. Shapley additive explanations is an XAI method based on game theory. In the context of machine learning, a SHAP value represents the average marginal contribution of a feature to a model's prediction. Here's a quick breakdown of what these mean. Average considers the contribution across all possible combinations of features, not just in isolation. Marginal focuses on the change in the prediction when that specific feature is included compared to when it's absent. And with respect to contribution, this change can be positive, which leads to an increased prediction of price, or negative, that can explain the decreased prediction in price, with the magnitude indicating the strength of the effect. Essentially, SHAP values tell you how much each feature individually and collectively influences the model's final prediction. In the context of pricing, it is understanding how each metadata feature contributes to the price that has been predicted by a particular machine learning model. In the demo, you will see a concrete example of this, showing which features contribute to the predicted prices with their SHAP values. This slide can help explain the SHAP values more intuitively. In the API that will be shown shortly, the response includes the estimated price range from the different machine learning models and the explanations for each. This slide shows the minimum, maximum, and mean estimated price. The explanations correspond to the SHAP values of the most important features obtained from the model predicting the mean price. For example, here it can be seen that when the value of the units metadata field is equal to entities, it has a positive SHAP value which marginally explains the price increase. However, when the format is equal to CSV, then there is a negative SHAP value and can explain to a certain extent the decrease in the estimated price. We can also apply XAI techniques for particular features within the dataset. For example, in the description metadata field. The description contains textual information about the dataset, and using the SHAP method, we can identify which words or phrases can positively or negatively influence the predicted price of the machine learning model. The text highlighted in red has a negative SHAP value, which means that the presence of this text marginally explains the decrease in the prediction of the price, whereas the blue highlighted text has a positive SHAP value and is one of the factors that can explain the increase in the predicted price. And now we showcase the demo of the first version of the pricing plugin API.
We will talk about the REST API. The static pricing plugin is a web service that adheres to HTTP, REST, JSON, and OpenAPI specification standards. In other words, it is an application that exchanges data when requested with other applications over the internet. The exchanged data are in the form of a JSON format. JSON is a human-readable format based on key value structure. The API will receive a JSON object that contains the data metadata, the dataset metadata, and will send back the response in a JSON object. The exchange happens over the HTTP protocol. The exchange is initiated by the API consumer via a remote procedure call that follows the RESTful API design principle. It means that the API is stateless, has a uniform interface, and has resource-based architecture. The API is described with the help of the OpenAPI specification standard in a JSON file. In a nutshell, OpenAPI standard specifies a common way of describing HTTP APIs. The main objective is to help build structured documentation and facilitate collaboration between organisms. So the static pricing API is described in a JSON file, and with the help of a Swagger interface and a backend server, we have a web page to visualize the documentation of the pricing API in an easy, common way. Now we will move to the pricing Swagger interface to explore the different API endpoints. How the Swagger interface looks like. It is the API documentation webpage. We have over here a section called Dataset Estimates. Under this section, we can see 4 endpoints or 4 mini services. The first endpoint provides an explanation for the estimated price. The second endpoint returns the similar datasets. The third estimates a range of prices. The fourth classifies a dataset in a specific category. For the first endpoint, it was developed by Cedar, and the 3 other endpoints were developed by Elastic. We will detail more the first endpoint, as the 3 last endpoints were explained by Santiago at the beginning. When we click on the tab over here, we can see the documentation of the explanation endpoint. So we have 2 parts. The first part is the request body documentation, and the second part is the response body documentation. So in the first part, in the request documentation, we have the method that we can use with this endpoint. So it is the post method. We have the type of the request body, which is a JSON object. We have an example and the schema of the request body. In this case, it is the metadata dataset. So we have description, category, history, etc. And when we click and open to see the details, we can also see the allowed values for every field. On the response part documentation, we have also the schema of the response object. Now to try this endpoint, we can just click in the try it out button on the left. So when we click there, the request body is filled by default with an example. So we can keep it as it is, or we can modify this example. It's the metadata dataset. So to invoke the endpoint, we just click on the execute button. So this is the documentation of this endpoint, and the try it out button is just to test this endpoint in an easy way. The final user of the API can use any programming language to invoke this endpoint. At the second part, we can see here the response that comes from the server. So now let's see what is happening behind the scene on the server side for this endpoint. Side, we execute the following steps. We pre-process the input data. We use the 10 models to estimate the prices, and then to get the minimum, maximum, and mean price, we compute the SHAP values for all models, and we extract the 10 most important features that contributed on the prediction. Then we compute the SHAP values for the text, and at the end we construct the response object. So we can see here the JSON response object structure. We have the price ranges, we have the model that predicted the minimum and the model that predicted the maximum price, and over here we have the explanation for the minimum price, the maximum price, and the mean price. When we open this section, we can see on the right side of this slide the structure of the minimum price explanation. This structure will be the same for the mean price and for the maximum price. So the computed most important features are rendered in this session. We have the input data followed by their value, the value provided by the user, followed by their SHAP values. Just a little precision concerning the dataset description, which is the only data input text. We extract the most important text and we split it based on its SHAP value. As a reminder, positive SHAP value means positive impact on the prediction and generally associated in the documentation to the blue color. And negative SHAP value, which means negative impact on the prediction, generally associated to the red color. The magnitude of the SHAP value gives an information about how strong the impact is. So, with the help of the shape value of the text, we succeeded to separate the text, the most important text, to the red text and the blue text. Now we will go back to the Swagger interface to explore further the other endpoints. To test the get similar products endpoint, I need to click on the try it out button to provide the dataset description and then click on the execute button. In this case, I will get back the similar datasets available on the server. To test the get price range endpoint, the same way I need to click on the try it out to provide the request body. Here I already copied the metadata dataset, so I have the category, the history of the dataset, the limitation, etc., the delivery method, the frequency of updates, and the description. Then I have to click on the execute button to get the estimated range of prices. So we can see here in the response part the minimum, the mean, and the maximum prices. To test the get classification endpoint, I need to provide the dataset description, like here the stock exchange real time, and hit the execute button. And I will get back the category of the dataset, in this case financial. To this session, the static pricing REST API is built with the help of the Fast API framework. The documentation is provided via Swagger interface, and the API can be used with any API testing program or any programming language.
Finally, do find a reasonable market-based price for your data assets using UPCAST static pricing plugin.